Hello everyone. In this video, I'll be extracting gold from rock. Last time, I got almost 13 grams of gold. I collected 600 to 700 kilograms of ore. How much gold will I extract today? I'll be using modern technology. I'll be using flotation. To extract every milligram of gold. I'm curious to see what I can come up with. Dear viewers, it's time to process the remaining 250 to 300 kilograms of rock. This ore could contain gold. I collected it nearby, near gold-bearing rocks, and there's plenty of this kind of rock there. First, I just pour it all out. Let's take a closer look at this ore. There are some interesting specimens. Look at this stone. It shows strong signs of oxidation and contains a lot of iron and magnetite. Other metals, including gold, can also be found in such samples. There are also some colored stones that show visible signs of copper oxidation. The copper content in these stones is quite high compared to the gold content. This ore also has a high content of magnetite and some other heavy particles. Now I'll be collecting this ore and crushing it in a stone crusher. I pre-wet the stone with water to prevent dust from forming. This is just preliminary crushing. Next, I fill the rod mill more than halfway with crushed material and run it for 2 hours. This is enough time for the pre-crushed material to turn into pulp. Now, dear viewers, I've adapted and operate this way. I fill the crusher, then crush the material for several hours, and then use a scoop to scoop out the contents through the loading hatch and wash them in a centrifuge. Then I reload the crusher and repeat this process until it's completely exhausted. This doesn't take up any extra time, and it's possible to process a ton or more of material this way. I crush the final batch, then remove the drum and empty it of its contents. This tactic is useful if there's a lot of ore. I turn on the centrifugal concentrator, and with this device, I'll catch every gold particle. This way, from 100 kilograms of pulp, I'll get the most valuable part, a concentrate containing gold. After 15 minutes, I'll have valuable concentrate, approximately 3 kilograms. Each wash can yield 1 gram or more of gold, depending solely on the ore. But this concentrate will require additional processing to extract all the gold. After enrichment, I take a sample, take a small amount of concentrate, and wash it with a prospector's pan. If there's no visible gold, I further process this concentrate using various methods. There are many, including flotation, alkaline leaching, and pyrometallurgy. This time, I didn't get much visible gold, so I washed all the concentrate with this pan, and I can show you some of it. This is all coarse gold from half the crushed rock. Some elusive gold remains to be extracted. The last batch I need to crush and wash again in the centrifuge. After centrifugal concentration and additional panning, I recovered all the gold from the last batch. Look, friends, at the fine gold flakes I caught on the concentrator mesh. After each wash, I carefully inspect the mesh on the concentrator lid. Sometimes there can be pleasant surprises there. There's a little more visible gold this time. Now I'll transfer this gold concentrate to a beaker. The next day, I prepared everything I needed to use flotation and extract the remaining gold dust from the concentrate. This time, I'll use a different method, and I'll need a few simple things. First, I add simple chemicals to the pulp to stabilize the solution. The concentrate contains many heavy particles, which quickly compact and settle to the bottom in a dense layer. After mixing and softening the solution, I add 50 mg of a simple solution to the pulp. This solution will create bubbles and foam, and I'll use diesel fuel as a particle collector. I'll continue mixing with a mixer, and this time, for flotation, I'll need a 12-volt water pump. I'll use this water pump as a pulp mixer. Passing air through the pulp is not recommended, as it will create a lot of empty foam because air will generate large soap bubbles. I need to create the right conditions, and a water pump is ideal for intensively mixing the pulp, creating microbubbles and rich flotation foam. This was the wrong decision. I connected the hose to the water pump and attached a weight, a piece of iron, to it to prevent splashing. At this point, I added some diesel fuel to the pulp, but the foam I was looking for didn't form. I continued running the water pump in this mode for another 10 minutes, but the buoyancy effect still wasn't achieved. Then I realized that simple mixing wasn't enough in this case, and I came up with a simple solution. Take a regular pipe and insert the pump hose into it, but not all the way, about 10 to 15 centimeters. Don't hold the pipe at a right angle or lower it all the way to the bottom. You need to control this process, creating intense circulation and a boiling effect on the pulp. Do you understand how it works? At this stage, I had just begun collecting flotation foam. And just when I was starting to see some progress, my water pump broke. Dear friends, I've carefully examined the first flotation concentrate, and here's what I know so far. When the foam settled, I saw an interesting sediment. It contained numerous yellow and gray particles, which I even managed to capture on video. I'll show you later. I fixed the water pump and resumed flotation. In 10 minutes, I had collected a whole tank of new flotation foam. This foam contains all the valuable minerals. Gold particles are visible to the naked eye, and I noticed that some of the larger particles sink back to the bottom after the foam settles. That's our gold. It's not working perfectly yet, but I'm very pleased with the result. I also noticed that the flotation froth settled quickly, in just a few minutes. I spent an hour on the flotation process, and it was time to filter the resulting concentrate. It's worth noting that the entire process had to be repeated the next day. The problem was that I was so absorbed in the process that I didn't notice that I was collecting not only the thick froth but also the pulp. After starting the filtration, I discovered a high clay content in the concentrate, so I decided to process it using the same method, using flotation. The second time, I tried collecting only the flotation froth, and everything worked perfectly. This footage isn't perfect, but you can see the gold particles shimmering, reflecting the bright light. There are a lot of these particles, and the video camera doesn't have enough pixels or macro focusing to capture a clear image. A lot of clay was extracted from the pulp. This is only remainder. I've already transferred the rest to a container. After 30 minutes, I completed the flotation process, and it is clear from the pulp that there is nothing valuable left in it. A small percentage of diesel fuel floats on the surface, and there is nothing in it except some kind of white turbidity. A double enrichment has been obtained. This time, only a small amount of clay remains from the pulp, and I begin filtering the resulting flotation concentrate. I see many yellow particles, most likely gold particles. As the foam settles, the larger particles settle back to the bottom of the container, but after filtration, everything will remain on the filter. I carefully wipe the container that held the flotation foam with a napkin, particles of the precious metal are stuck to its walls. The next day, all the flotation concentrate was filtered, and I saw this image. Look at how many different particles there are, including the yellow ones. Unfortunately, my video camera doesn't have enough pixels to capture a clearer, larger image. I also noticed that this flotation method captures few sulfide minerals, meaning it can be used to process pulp without prior enrichment in a centrifugal concentrator. I roll up the filter and it needs to be fired. I'm interested in what color the concentrate will be after firing. After firing, I carefully examined the contents, and here's what I know. The yellow particles are still visible and have a characteristic metallic color, similar to gold, with slight variations. Numerous silvery particles are also visible, making their identification difficult. Because the material was heated to red heat, the particles exhibit a rainbow of colors. This effect may be due to oxide films that form when metals are heated. Now I'll melt everything together and create a gold lead alloy. I'll use my conical crucibles and caustic soda instead of special fluxes. I place the crucible in a muffle furnace and heat it to 800 to 900 degrees Celsius. This time, I won't be adding slag, as there's quite a lot of material. I'll melt it in batches, as I can't fill the crucible all at once. Then, I take the resulting concentrate after washing it with a prospector's pan. It contains visible gold. I transfer this sediment to a paper filter, not for filtering, but to drain off excess water and roll it into a bundle. Before the muffle furnace gets too hot, I load the wet bundle of gold precipitate into the crucible. Adding wet precipitate to hot alloys isn't safe. It's best to do it now, and let the moisture evaporate. Once the first batch had melted, I removed the crucible and added the next batch of flotation concentrate. There is no need to rush at this stage. It's better to put everything together from several parts than to ruin everything. Several hours passed, and now the moment has come when everything has melted and you can pour the contents into another cone mold, preheated. Precautions must be taken to protect your face and hands from splashes. Everything has already cooled down, and now, with a simple blow to the floor, I take out all the contents from the cone mold. I have obtained an alloy of gold and lead, from which it will not be difficult to extract gold. 99.9% of all gold is extracted. But if I used chemistry to extract all the gold from the concentrates, it would take me several days. It would be a waste of time. And it took me 2 hours for this procedure, and it will take the same amount of time for the cupellation. This time the slag has a characteristic brown color. The alloy turned out to be brittle and vitreous, which means everything is fine. For cupellation I will use a simple composition, half and half mixture of gypsum and cement. This composition absorbs lead vapor well, which it absorbs like a sponge. Last time I received this noble and sunny piece of gold, almost 13 grams from 300 kilograms of selected rock. And now the X hour has come, my favorite stage of production, and again I get goosebumps. Excitement appears, like in a casino. The crucible has warmed up, and I carefully put Workley's alloy into it. During this period of time it always seems to me that time stops. And now, dear viewers, the long-awaited moment has come to find out how much gold I managed to extract from this batch of ore. I take out the crucible and see that cracks have formed and gold has seeped into them. First, I carefully remove the untouched gold bar, and while the mold is hot, I remove the remaining gold balls that have leaked into the cracks. There is no need to be upset. I have had many such situations. Most often the cracks are not deep, up to 1 centimeter. In any case, I do not throw away these fonts. They accumulate and are sent for recycling, since they may contain minor remains of grains of precious metals. I boil all the resulting pieces of gold in diluted nitric acid, in order to get rid of lead oxides. This takes 10 minutes. Now I can remove these gold pieces from the beaker and weigh them. This time I have 3 pieces, and melting them into a single bar won't be difficult. That's how much gold I've extracted from this not-so-rich rock. I consider it an acceptable result, even excellent. Considering that this rock can be harvested by hand by the ton without any additional effort or expense. I take these bars and place them on the scale, which reads 5 grams 26 milligrams of 850 karat gold. That's how much gold I've extracted from this not-so-rich rock. I consider it an acceptable result, even excellent. The total amount of gold I brought from this batch and extracted is 18 grams 23 milligrams, simply excellent. Dear viewers, this video ends here. Next time I want to extract gold from an unusual material that you can see. In this video I got the noble metal gold, but to get it I had to use a number of technologies. I extracted natural gold without changing its chemical composition, just as it is. As you can see, this is not easy to do. See you soon, gentlemen. There are many difficulties and trials ahead.